Hi everyone, welcome to Fluid Mechanics Lab, and this one is our test system today. And the experiment one is pipe flow experiment. And the information about the experiment one you can find in UTS online. And this one is the lab note, you can download in UTS online. And if you have a look in the lab note, you know that today we have two small experiments. Experiment A, friction loss in pipe flow, and experiment B, measurements of flow rate in pipe flow. Okay. And firstly, I will introduce about test system. And this one is our test system. Firstly, we have this one. This one is a water tank. Okay. And after the water tank, we have a pump. And after the pump, we have a flow meter. From the flow meter, we will have volume flow rate of water. And in the flow meter, you see we have two kind of units. GPM is mean gallon per minute, and LPM liters per minute. Okay. And in the calculation in our lab report, you have to change the volume flow rate units to SI unit. And SI units of volume flow rate is meter cube per second. Okay. And after the flow meter, we have a pipe system. You see we have 5 pipes. From pipe 1 to pipe 4, we use in experiment A, and the last one we use in experiment B. Okay. And for example, for experiment 1, we use 4 pipes here. And if you have looked in the last note, you know that we have 2 PVC and 2 galvanized pipes. The small one, small PVC, and bigger one, small galvanized and bigger one. Okay. And in one pipe, we have 2 measuring points or 2 tapping. Okay. And this one is point 1 and point 2. And the pressure drop between 2 measuring points will be measured by the manometer, this one. Yeah. In the manometer, we have so many kind of pressure unit. We have PSI, we have kPa, Pascal, bar, millibar. But in the lab report, you have to change pressure unit to SI unit is Pascal. Okay. And in the experiment 1, X group of students will conduct experiment in 1 PVC and 1 galvanized pipe. We have 4 pipes here, but X group only conduct experiment in 2 pipes, 1 galvanized and 1 PVC. And in 1 pipe, one group, X group of students will conduct experiment at 2 different volume flow rate. Okay. So this means a group of students will have 4 data sets. One data set includes pressure drop for the manometer and volume flow rate for the flow meter. Okay. And about the procedure, in experiment 1, you have 8 steps from step 1 to step 8, step 3. Okay, we have to finish in the lab. Okay, and today I will show you about step 1 to step 3. And from step 4 to step 8, you have to finish in the lab report. Okay, we will start with step 1. In step 1, you turn on the pump and wait until steady flow. For example, today we will conduct experiment in the big galvanized pipe. Okay, to conduct experiment in this one, we have to turn on this one and off other. Okay, and this one we used to turn on the pump. And we wait 30 seconds to have steady flow. And in the experiment, in the step 1, you get ambient temperature. For example, today you can assume an ambient temperature is 20 Celsius. And at 20 Celsius, you have the water viscosity from the textbook or course note. Besides, you will get the surface roughness E of the PVC and galvanized pipe. The roundness you have in the hot note or textbook. Okay. And step 2, you can pressure drop from the manometer. Okay. For example, now the pressure drop is 8.2 kilopascal. Okay. And pressure drop is 8.2 kilopascal. Step 3, with the water flow rate. Water flow rate now is 84 rpm per minute. So you have 100 set. Pressure drop 8.2 rpm and water flow rate 84 rpm. Okay. And now we will change the volume flow rate. The smaller volume flow rate, you see the white one now. And now we have volume flow rate is 46 rpm. Okay. At 46 rpm, pressure drop is 3 rpm. So you have two data set in the galvanized pipe. And turn off. You have two data set, two different volume flow rate of the galvanized pipe. And now we change to, and similar, you have two data set in the PVC. We can choose the smaller one or bigger one. Okay, two data set in PVC and two data set in galvanized pipe. We finished step from step 1 to step 3. Okay, and from step 4 to step 8 in experiment 1, you have to finish in the lab report. Okay, and the detailed instruction you can see in the video or in ETS online. Okay, and now we move to experiment B, measurements of flow rate in a pipe. Okay. In experiment B, we will conduct experiment in the last pipe here. In this pipe, we have 3 devices: the venturi, orifice, and sudden expansion. Okay. The dimensions of venturi, orifice, and sudden expansion you have in the lab note. Okay. And similar to experiment 1, in experiment 2, with this device, for example, with the sudden expansion, you will have one data set. One data set includes pressure different between 2 measuring points of the device and water flow rate from the flow meter. Okay. So you have one data set for sudden expansion, one data set for orifice, and for venturi, you see we have 1, 2, 3 measuring points. So for venturi, you will have 2 pressure different and 1 volume flow rate. Okay. So you will have 3 data sets in 3 different devices. And similar to experiment 1, procedure from step 1 to step 3, I will have viewed in this video. And from step 4 to step 8, you have to finish in the lab report. Okay. For example, I turn on the valves of the amplifier and off other. And for this experiment, the pressure difference between the 2 measuring point of device, we have another manometer, this one. Okay. And turn on and wait for 30 seconds to have a steady flow. Okay. For example, now we conduct experiment in sudden expansion, and you will have 2 data set. Sorry, 2 data in the sudden expansion. Pressure different for the manometer and volume flow rate for matter. Okay. For example, now the volume flow rate is 41 rpm, and at 41 rpm, the pressure difference between two melting point of the sudden expansion is sorry, here is 22.3 kilopascal. Okay, so you have 100% in the sudden expansion. Similar, you have 100% in the orifice and 100% in the venturi. Okay, and turn off. So I finished from step 1 to step 3. From step 1 to step 3 is the procedure. From step 4 to step 8, you have to finish in the lab report. And the detailed instruction you can see in the video if there's online. Thank you.